you want to stay organized, put it in a notebook somehow. We're going to just do quick 4 little review problems before we jump back in. We got some doozies today in our notes, but that's all right. We can handle it. Here we go, 4 review problems. Okay, so the first one really doesn't need any directions. We're just solving that equation. Who's got a plan? Who has a plan for solving that? Yes, indeed. We're going to loop-de-loo it. And so when we loop-de-loo, we always start right here with the base. So it's going to be 4 to the 3rd equals x. So the answer is 64. Everybody okay with that? Now, we've looked at much harder equations than that, but the bottom line is, when you have an equation with logarithms, you want to get that logarithm by itself, and then you want to loop-de-loo it every time. Now, this one is kind of a special case of that. This is really not an equation, the way that I have it written. It also isn't typable in on my calculator because it's a base 3 and I don't have a base 3 button. So there's a little, it's called the change of base formula, but it's more of a technique than a formula. To evaluate this, we take the log of 16 and divide it by the log of 3. So it's the log of this number divided by the log of this number. Now, I'm going to walk you through this problem the long way, but if you can remember this, the log of 16 over the log of 3, then you are going to be all set. We'll get an answer to that because that requires our calculator. Log 16, close parentheses, don't forget that, divided by the log of 3. So I got 2.5237. So this kind of problem, guys, can always be done with this little shortcut. Always. But I'm going to go through this problem with you in case you forget the shortcut, or if you're just one of those people that likes everything to be step by step, we're going to go through that. Before we do, though, because I need the space over here, let's finish up these two, and these are easy. This one is 7, because remember, when those two numbers are the same, that's one of your properties of logarithms. When this number and this number match, I don't care what they are, if they're the same, they cancel out, and the answer is the other number. Unfortunately, there are just some things we got to remember, and that's one of them. And then for this, I just wanted to take us way back to the beginning of the chapter. This is an exponential function. Would you say that this represents an increasing or a decreasing function? Increasing or decreasing?
Is it decreasing?
Absolutely, it's decreasing because this number is less than 1. That's the key. This number right here, the one that has the exponent, is either going to be more than 1 or bigger than 1. If it's more than 1, it's a growth problem. And remember, growth problems graph like this. Or this one, it's less than 1, so it's a decay problem, and it graphs like that. Next question. Okay, so this is a decay. Okay? Decreasing. Decreasing. What is the percent of decay? Yes, indeed. This is a 7% decay problem. Because remember, to figure out if it's growth or decay, you look at this number. It's either bigger than 1 or less than 1. The amount that it's bigger than 1 is the growth. The amount that it's less than 1 is the decay. So this is 0.07 less than 1, so that represents a 7% decay. All right, is that bringing back memories? Remember, all this stuff's in your notes. You got to go back and look it over if you've forgotten it. But now I'm going to come back to this problem, and I want to show you a different way to do it. Groupies, I don't care how you do it. I'm giving you another option. My favorite option is the change of base formula. Log of this over log of this. But I want to show you how this fits with the other stuff that we've been talking about. Let me just set it equal to x. Because that's what I want to know. What is this thing equal? I already know, but I'm doing it again. This is the setup. So I'm going to loop-de-loo it. So I have 3 to the x equals 16. Now that's the next. Go ahead.
Well, I was going to say you have to make base the same, but you can't do that because I don't think 16 goes into 3.
You're right. Very, very good though, Jacob, because one option, this is called an exponential equation, and one option to solve it is to make these two numbers match. So, for example, if it had been 3 to the x equals 9, then we'd have no problem. 3 to the x equals 3 squared, so x equals 2. But you're right, Jacob, 16 is not an integral power of 3. This isn't 3 to an integer power. So I gotta somehow get this x down. Who remembers how we did that? We just did it. How do we get this x down? Exactly. So I'm going to take the logarithm of both sides. Then I can pull that x down. And you see what's going to happen, guys? When I solve for x, I'm going to divide by the log of 3. And look what happens. Didn't I get the same thing I started with over there? So this is the long way. I'm not telling you this is the way I think you should do it, because it's not. But it's an option for you if you forget what to do with this guy. If you forget that this is log 16 over log 3, then you can always work through the process by loop-de-loo, logging both sides, pulling the exponent off, and dividing. All right, anybody have a question about anything I just talked about? Shake some of those cobwebs out. All right, let's get our notes out then. And according to my records, which I hope are right, we are still in section 3.5, and we're ready for 3D. Now, this is a logarithmic equation. Obviously, it's an equation with logarithms in it. There's something different about this equation, though. Can anybody tell me? Look at the ones we did yesterday. Look in your notes there. What's different about this one?
It's got a log x on the side, so it's like it's not really a number. You can subtract to the other side.
Okay, so basically what you're telling me, Jacob, is I got 2 logarithms in this problem. All of my other problems had only one logarithm, and my job was to get it by itself, loop-de-loo, and I was done. Well, let me tell you, this is very bad. We can't solve the equation, any equation, if we've got more than one logarithm on a side. So, what I need for you to think about is something we talked about in December, somehow taking these 2 logarithms and condensing them into one logarithm. That's what you have to do. You cannot do the problem with two separate logarithms. They have to be condensed. This is one of your properties. Does anybody remember how you take an addition of two logs and turn it into one log? Anybody remember how that works? I heard a whole bunch of people, and I love you all, good job. I heard a whole bunch of people say you multiply them. There's a property that says, and you already have these written down, so I don't think you need to write them down again, but if you don't have them written down, you need to write this down. When logarithms are added, and I may have used different letters when I did it before, but when logarithms are added, it means the numbers have been multiplied. So I am going to take these two, I'm going to smush them together into one, and that means I have to multiply this and this. So now I have an equation that says the log of x squared plus 3x equals 1. That, my friends, is solvable. I have one logarithm, so I'm going to loop-de-loo it. Okay?
Wait, put the addition sign when you condense them.
What now?
Why did you add the addition sign when you condense them?
Oh, that's supposed to be a minus. Thank you, Ellie. Thank you, thank you, thank you. That's my mistake. Thank you. Thank you. Yep, that's supposed to be a minus. I should have just copied that down. I shouldn't have changed anything. Good. Thank you. Now, I need to loop-de-loo it, but there's something missing. What's missing?
The 10.
Yeah, the base is missing. If you're going to loop-de-loo, this is where you start, and that number was missing. So again, something you just have to know is that when you see an LOG, it's a base 10. There's an understood implied 10 there. So now I can loop-de-loo it. So 10 to the first equals x squared minus 3x. 10 to the first equals x squared minus 3x. Now I need to solve this equation. What kind of equation is that? It's a quadratic. How am I going to solve this?
We'll subtract 10 to the other side, factor it out.
Yeah, and then sure. So one option, Jacob, that you have suggested is factoring, and this one does factor. But of course we know that there are quadratic equations that don't factor. So what would we do if it didn't factor, or if we just didn't want to factor it?
Use the quadratic equation.
Exactly, the quadratic formula, that's right. So you do whatever flips your switch. This one factors. That's quicker for me, so I'm going to go ahead and factor it. But you can always use the quadratic formula when you are solving a quadratic equation. So this time I get two, well, it's a quadratic, so of course I get two answers. I get 5 and -2. Everybody good so far? All right, we're not quite done with this problem because there's one more wrinkle. That's an extraneous root. The reason that it's extraneous is, let's go back to the original problem, and let's let x be -2. That's what it says, x is -2. Type in log -2 on your calculator. What happens? Just type log -2. What? Error. It's not possible. And this goes back, you're not gonna like me, but this goes all the way back to your BFFs, kids. Do you remember when you memorized the logarithmic curve? And it looked like this? This was y equals ln x, it's the log x, any logarithm, right? What's the domain? What are the x values here? Aren't they bigger than 0? You don't have logarithms over here. That number right there, this number right here, can never be negative, ever. So make sure that when you're solving a logarithmic equation, you double check to make sure that this position and this position, the things that you are logging, log this plus log this, in this case, the two things that we're logging must be positive. Okay? Now, before we go on, I want to talk about something because I want to make sure that you don't throw out every negative answer you get. I want you to think about this problem. Now, I'm making this up, so it's not going to actually be valid, but it's going to make my point. So I need everybody to bear with me. Okay, if I had a problem like this, and I solved it all out, and I got -1 as my answer, that is not extraneous. Because when I put -1 into the problem, this would be positive, right? And this would be positive, and that's all that matters, is that they're positive. Similarly, if this had been the problem, and I got 4 as an answer, that's a positive number, but it's still an extraneous root, because when I plug it in here, it makes this negative. Am I making my point? You can't throw an answer out until you put it back in here. This is where it matters if it's positive or negative. Not down here. This is where it matters. All right. Any question about anything I've been blabbing on about? Talked about a lot of things. Anything need clarified? Okay. All right, here we go. E. Oh, this is a doozy. Ay, 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 ay. Sometimes I say really important things, and one of the really important things I said today is you cannot solve a logarithmic equation. You cannot solve a logarithmic equation if you have more than one log on each side. This is a problem. There are 2 logarithms. This is not a problem. We're going to be fine with that. This is a problem.
Would you take like the log 7 and log 7(3) and make that into one whole entire thing, and then take log 7(5) and subtract that to the other thing, and then make it into a whole other thing?
Actually, you could, but that's a good observation, Jacob. But we can do it much easier than that. That will work. What you just said absolutely will work. But we're going to do it easier than that, okay? We are going to have to combine these 2, though. Okay, I'm going to combine these 2. Now, when I put them together, notice that's not a plus. That's a minus. So when I put these together, they're going to go together not as a multiplication, but exactly. So this is going to be 2x over 3. So the 2 logarithms get smashed together into one logarithm. Since that's a subtraction, when they come together, it becomes a division. Now, we haven't seen this before. This kind of problem we haven't seen before. But it is easy. Here's the deal, folks. I want you to think about this. If I told you that the log base 7 of x equals the log base 7 of 10, what do you think x is? Exactly. If you have a logarithm with the same base on both sides, then they're gone. And 2x over 3 equals 5. Now, that only works if they have the same base. And in high school pre-calculus, they're always going to have the same base. So I'm not going to give you anything that's really hard. The whole point, though, is there will be somebody out there when we take a test who drops them out at this point. And you can't do that. You can't drop them out until you have one on this side and one on this side. Then you can drop them out and solve your equation. So it looks like x is 15 halves. There are basically only two kinds of logarithmic equations. There's the ones that have a log on both sides, so you just drop out the logs. And then there's the one that have just one logarithm, and that's when you loop-de-loop. So if you have one logarithm, you loop-de-loop. If you have one on each side, you just drop them. Easy peasy. All right, let's look at F. Take a minute and see if you can figure out what to do with F. See if you can figure it out. Any brave soul out there want to venture some ideas about answers?
Negative 2/3.
One answer, one idea is negative 2/3. Anybody have a different idea? Or are we all getting negative 2/3?
Is it no solution?
No solution is another answer. Well, let's talk about what you did. Who said negative 2/3? How did you do that? Where'd that come from?
Oh, me?
I don't know.
Well,
Whoever said it.
I just multiplied x and 4.
Okay, so you put these together. Very good. That's exactly what you want to do. Kids, you cannot do this problem if there are two logarithms here. They have to be put together. Since that's a plus, you're going to put them together as a multiply. Now you've got one log on each side, so 4x equals x minus 2. And right there is the negative 2/3. Now, who said no solution?
Me.
Why?
Because you plug it into the x and it's a negative.
Exactly. So, but in a way, both of you, I mean, this is absolutely right. I get where the negative 2/3 came from, but remember, you gotta always plug it back in, and if this is negative, or this is negative, you're out. So the answer to that problem is indeed no solution. Everybody okay with that? All right. Okay. Oh, Lord. Look at G. That's what we're ready for now? Ay, 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 ay. Help. Who's got an idea? What might I do to get this thing started? I love that idea. We're going to multiply by 3. Yep. So now I have this. Now I want you to remember what this right here means. What does that mean? 2 to the negative x.
Put it in the denominator.
Uh-huh. So we got 2 to the x minus 1 over 2 to the x equal to 12. Now, so far, I haven't done anything that you're not capable of doing, right? It's a scary looking problem, but so far it's been easy. Now, let's take a look at where we are now. What might we do at this point?
Multiply both sides by 1 over 2 to the x.
Not by 1 over 2 to the x, but just 2 to the x. That will clear this fraction out. So I'm going to take my equation, which is this. This is my equation. And I'm going to multiply through by the denominator. Because that will get rid of that. And now I don't have any fraction left. This is just going to be a minus 1. Now, think back, all the way back to Algebra 1, and certainly Algebra 2. What do you do when you multiply 2 to a power times 2 to another power? What do you do with those exponents?
Don't you add them?
You do add them. So this is just 2 to the 2x. Because when you multiply like bases, you add the exponents, and x plus x is 2x. Now, you can also think of this, open up your mind, challenging you a little bit today. You're taking 2 to the x times 2 to the x, so you could also think about it as 2 to the x squared. You're multiplying something times itself, so what you're really doing is squaring it.
Question.
Uh-huh.
So why is the base not 4 now?
Okay, let's talk about that. I understand what you mean. Let's go back. I hope I don't need that anymore. Let's think about this for a second. If I had 2 squared times 2 to the 3rd, okay? And we're going to multiply them together. This means 2 times 2, and this means 2 times 2 times 2. So all together, what have I got there? 2 to the 5th? I still have 2's. When I'm multiplying a bunch of 2's, in the end, I'm still going to have 2's. The base never changes. Does that make sense?
Yeah.
All right, the base never changes. All right, so let me get back here to where I am. Now, this is where you may have never seen anything like this before. So I really need you to open up your minds now and go with the flow here. I'm going to bring this over so that my equation is equal to 0. So I have 2 to the x squared minus 12 times 2 to the x minus 1 equals 0. I simply took everything I've got and moved it over equal to 0. Now, remember, in expressions like this, you never combine. That can never be combined, ever, 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 ever. So it's going to stay 12 times 2 to the x. Now, get ready to be blown away. This is a quadratic equation. This is an equation that we're either going to factor or use the quadratic formula on. And here's why. Let m equal 2 to the x. And I'm just picking m as a random letter. make it A, Q, J, I don't care what you make it. But let's do a substitution here and say, okay, 2 to the x is m. So then what I've really got is m squared minus 12m's minus 1. Do you see it, guys? Do you see that? That's a quadratic equation. It looks way harder because of the 2 to the x stuff, but that's a quadratic equation. Now, let's forget this for a moment. Let's just deal with this, because that we can handle. Does that particular equation factor?
No.
No. So we're going to use the quadratic formula. All right, so here we go. I'm solving this equation in the box. Let your mind go. Try to hang with me. I'm going to use the quadratic formula. So, negative b plus or minus the square root of b squared minus 4ac all over 2a. Got a double negative in there, so that's a 148. Now, this is a case where I'm going to allow you to go ahead and round, so it's not, this is a hard enough problem already. So let's go ahead and get a couple of decimals for that. You don't, I know that simplifies, don't worry about it, we need the decimals. So 12 plus the square root of 148 equals, divided by 2, you should get 12.0828. 12 minus the square root of 148 equals, divided by 2, negative 0.0828. So let's stop right there and make sure everybody's got that. Alrighty? Now, don't get excited. This is not the answer to the question. The question didn't have any m's in it. I stuck those in. So what does this stand for here? We'll come back over here now. We said m was 2 to the x. So what this really says is 2 to the x equals 12.0828, and 2 to the x equals negative 0.0828. Did everybody follow that move? Remember in the beginning, or somewhere in there, I substituted in m for 2 to the x. Well, now it's time to unsubstitute. How do I solve that equation, guys?
You have to use log.
You do. I'm going to take the logarithm of both sides. This is the problem that never ends. So we have x log 2 equals log 12.0828. And then we'll divide. Everybody remember this from yesterday? So one of my answers is the log, of 12.0828, close parentheses, divided by the log of 2. 3.5949. There's one of my answers. Now, am I going to do the same thing here? Yep. But something wild and wacky is going to happen. What do you notice? can I do this? No, you can go ahead and try, but it's not going to work. You're not going to get an answer because you can't take the log of a negative. That's how you get error messages. So that answer isn't going to work for us. So this is the only answer to the problem. Oh my gosh. I'm sure some of your heads are just spinning. So what we're going to do is skip H for a moment and do I, because I is a very, very similar problem. So we're going to skip H. We'll do it tomorrow or whenever I see you again.
I have a question.
Yep. Oh shoot, I just erased everything. Yep.
So does m equal anything, any number to the x in situations like these?
Okay, yes, we're going to substitute in when it's necessary. We're going to, if we have, like in this problem, we're going to have an e to the x. So I'm going to let m be e to the x.
Okay.
And that substitution is not necessary. I do it because it helps you solve the equation when it's m squared and not e to the x squared. Okay? So it's meant to simplify the situation, not make it harder. All right, here we go. E to the x plus e to the negative x over 2 equals 4. That's the beginning. Josh Ramsey, can you remember or think about what we might do first?
Multiply the 2.
Absolutely, absolutely. So e to the x plus e to the negative x equals 8. Rory, do you have an idea? Think about the problem we just did. Do you have an idea what we might do next?
You add logs to both sides.
Well, that's very problematic with the plus sign there.
Yeah, that's what I was thinking.
Yeah. So no, before I do anything with logarithms, I need to maybe simplify this guy. What is e to the negative x? What's another way of writing
1
it?
over e.
There you go, 1 over e to the x. So that's what I'm going to do. I'm going to write that as 1 over e to the x. We don't like negative exponents. So we'll rewrite it as 1 over e to the x. But unfortunately, in rewriting it, I now have a fraction. So now I'll multiply through by e to the x to get rid of that fraction. See how that's going to cancel there? Now this is the part where sometimes we get tripped up. E to the x times e to the x is e to the x squared. Or e to the 2x if you prefer to write it that way. This is e to the x times itself, so it's e to the x squared. Minus 8e to the x plus 1. Everybody with me? Now, this is a quadratic equation. I'm going to do my optional substitution. I'm going to say, all right, this looks too complicated, so I'm going to let e to the x be m, so that my equation is m squared minus 8m plus 1 equals 0. Now, truly, this is our second time through. Who is confused about something here? Let's talk about it before we move on. Okay. Well, how do I solve that? What am I going to do to solve that?
Quadratic equation.
Yep, I'm going to need the formula. You might get lucky sometime and get a factorable one. Certainly you can factor if it factors, but usually they don't factor. So m equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to get a couple of answers from my quadratic formula. And again, I know this simplifies, but don't worry about it because you need the decimal anyway. So 8 plus the square root of 60 equals divided by 2. 7.8730. 8 minus the square root of 60 equals divided by 2.1270. Okay, everybody, every single person out there, all of you, should be doing the quadratic formula and coming up with these answers. Do we match? Yeah? Okay. Are these the answers? Is this what I put in the answer blank? No. Remember back in the beginning, and I've erased it all now, hopefully you still have it. What did I let m stand for?
Well, EX.
E to the x. So this really says e to the x equals 7.8730 and e to the x equals 0.1270. Would you agree with that? How do I solve those? Those are e's now. So what do you think?
You take the ln.
Absolutely. We're going to ln both sides. Now again, the best part about math is there's always more than one way to do the problem. So you are free to log if you want. But I wouldn't, because remember, if you ln e, your x is just going to be whatever ln 7.8730 is, because this part cancels. And the same thing here. This x is going to be whatever ln 0.1270 is. Does that make sense to everybody? It's a cool thing about using ln when you've got e's in your problem. Final answer, 2.0634 or negative 2.0636. Those are really close. My guess is they'd have been the same if I didn't round these off like I did. But it's okay. That's all right. There they are, the two answers to the problem. Oh my gosh, you guys have done an amazing job. Those are very, very tough problems. We're going to stop there. That's kind of mentally exhausting. Next class, we will finish up 3.5. So if you want to go ahead and start on the homework, that's fine. But I'm not assigning it yet because we haven't finished, but we will finish next time. Okay? And just to whet your appetite a little bit, next time we'll also start our word problems, and they are fun word problems because they're all about like money and banking and all kinds of great things. So that'll be something to look forward to. But for today, we're done. So you can check out. Anybody have any questions or anything? Everybody good? All right. Have a great rest of the day, you guys. Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye. George.